Hello students, today we will discuss the important law, that is Graham's law of diffusion. This law is mainly used to compare the speed of the gas, the velocity of gas, which gas moves faster, which gas moves slower. We can know using this Graham's law of diffusion which gas moves faster. If you take a mixture of gases, which gas moves faster than the other. And then diffusion, already you know, diffusion is very important property of gas, that intermixing of gas with one another, that is called diffusion. The gas can intermix with one another. You know, the gas has such characteristics, such quality, that it has no barrier. Every gas can mix one another. There is no separation between color gas and colorless gas. There is no separation between foul smelling gas and bad smelling gas and sweet smelling gas. All can intermix. So we should learn this characteristic from the gas. We should not have any barrier. We should not deviate from one another. That means we are not separated. We are all Indian. That means we are not differ from one another in caste, religion, like this, color. So this quality, that we are getting this knowledge, this message from the gas, that we can mix one another, there is no separation. So we should not, as we are Indian, we should not, that create a difference among us in name of the caste, creed and religion and color. So let us discuss what are the statement of Graham's law of diffusion, what are the formula derived by Graham's law, what is the relation between the rate of diffusion with the velocity, with the temperature, with the mass. Let us discuss. Graham's study that the rate of diffusion of gas, statement is like this. Statement of Graham's law, that the rate of diffusion of gas. Diffusion means intermixing. The speed, you can say the rate means speed. The rate of diffusion of gas is inversely proportional to what? Vapor density. Inversely proportional to vapor density. What is vapor density? Already know. Vapor density means is the relative density compared to hydrogen. That same volume of gas, what is the weight? What is the mass of same volume of gas with the hydrogen? The mass difference between the different gas with respect to hydrogen, that is vapor density. Suppose you take VML of unknown gas. VML of that unknown gas, what is its weight? Compare this weight with hydrogen. Compare with this weight with hydrogen. This is called vapor density. So vapor density is the relative density, relative mass of the unknown gas with respect to hydrogen. So rate of diffusion of gas is generally inversely proportional to vapor density. If the density or vapor density is more, then this relation, how rate of diffusion of gas is inversely to square root. That is the square root of the vapor density. Square root means that is a relation that this mass is not inversely related but inversely related with respect square root. So that means suppose gas first gas R1 is inversely proportional to first gas, suppose G1, square root of first gas, that is vapor density is G1. Second gas, let it be R2, is also inversely proportional to square root of second gas, D2. This is the rate of diffusion of first gas, this is the rate of diffusion of second gas. This is your relation 1, this is your relation 2. If you take those both relations, so if you write R1 by R2, rate of diffusion of first gas with respect to rate of diffusion of second gas will be how much? It will be d2 upon d1 square root. Because it is inversely, the ratio will be just interchanged. So R1 R2 is equal to d2 by d1. This relation is the first relation of Graham's law, that the comparison of a rate of diffusion with respect to vapor density. But we know vapor density always what? 2 times of molar mass is always 2 times of vapor density. If you multiply 2 here, now it will be 2d2 by 2d1. So there will be no change. If you multiply numerator 2 and denominator 2, there will be no change. But 2 into vapor density is always what? Molar mass. Always molar mass. Because 2 when multiplied by vapor density is always molar. Because if you compare the hydrogen molar mass is 2. So 2 is divided, automatically 2 will multiply with vapor density to get the molar mass of one gas. So 2 into d2 is equal to m2 and 2 into d1 is m1. It is a relation 2 when vapor density multiplied with 2, result will be molar mass. So this is the important relation with respect to rate of diffusion, with respect to vapor density and with respect to molar mass. That what does mean this relation shows? That rate of diffusion is inversely proportional to molar mass. That means if mass is more, that the molar mass is more, then the rate of diffusion will be slow. Which gas is the lightest gas? Hydrogen. Molar mass is the lowest. That means hydrogen has maximum rate of diffusion, highest. If you compare with the other gases, hydrogen has a highest rate of diffusion because molar mass is the lowest, that is 2. So R is inversely proportional to M. So this relation R inversely proportional to diffusion, that is the rate vapor density, but here this is inversely proportional to molar mass. So this relation, but you can take this is the case 1. Suppose you take VML, suppose VML of gas takes T1 seconds to diffuse. Another VML of gas takes T2 seconds. Then what is the relation between the rate of diffusion? So what is the rate of diffusion of first gas? R1 is equal to V by T1. What is the rate of diffusion of second gas? That will be R2 is equal to V by T2. Here the relation between the time factor. If VML is diffused in this T1 time, if R2 another gas same VML takes T2 time, then what is the comparison of rate of diffusion? R1 is equal to V by T1. This is R2. Here volume is taking constant. So R1 to this. So now what is the R1 by R2? Now R1 by R2 is equal to V will cancel. That is T2 by T1. This is also another relation. So this is R1 R2 is equal to D2 by D1 square root is equal to M2 by M1 square root. Now you are getting is equal to T2 by T1. But if T is constant, we can take this relation that R1 by R2, if taking time is constant but volume is different, it will be V1 by T, it will be V2 by T, rate of diffusion. V1 by T, here V2 by T. So T cancels, that is R1 by R2 is equal to V1 by V2. This is also another relation. Taking what? Volume. This is the volume. V means not velocity. This is the volume. So R1 by R2 is equal to V1 by V2 is equal to T2 by T1 is equal to D2 by D1 is equal to. So now we are getting an important relation. R1 by R2 is equal to D2 by D1 square root is equal to what? M2 by M1 square root, which is equal to, what is the relation? That T2 by T1 is equal to V1 by V2. So this relation is important relation that related to Graham's law. What is R1? Rate of diffusion of first gas, rate of diffusion of second gas is equal to vapor density of second gas to the first gas, molar mass of second gas to the first gas, time taken for second gas to the time taken for first gas, is the volume diffused, amount of volume diffused, the volume diffused V1 by V2. So this relation you have to remember, rate of diffusion with respect to vapor density, with respect to molar mass, with respect to time, with respect to volume. There is an important relation you write down, R1 by R2. R1 by R2, if you write this one in terms of pressure, in terms of pressure is equal to P1 by P2 then square root of V2 by V1. This relation also remember. R1 by R2 is equal to P1 by P2 into D2 by D1. This relation, another relation also remember. This relation also very important for problem. Then R1 by R2, if you use that is temperature, not time. If you use temperature, that will be T1 D2, T1 into D2 by T2 into D1 square. This is also another relation. This is also another relation. So every formula you remember. So this is the important relation. You can say 1. This relation is 2. This relation is 3. So this is regarding the formula of Graham's law of diffusion, comparison of rate of diffusion of different gases with respect to their vapor density, with respect to their molar mass. Molar mass means weight. Here with respect to, this is your time, and this is with respect to volume of evaporation, volume of escaping the gas, and with respect to pressure and density both. Here with respect to temperature and density both. So you have to remember this relation for calculation. Let us discuss one problem. Problem is like this: compare the rate of diffusion. Compare the rate of diffusion of hydrogen and oxygen gas. I can compare the rate of diffusion, which is moves faster and how much. For this, here no data is given. Here only the name of gas, hydrogen, oxygen given. But we have to apply the formula R1 by R2. R1 let it be H2. Here is O2 is equal to, we know that relation, because the gas name is given means already you know molar mass. This relation already know. What is the relation? M2 by M2 means here O2. This is the second, and here M1 is H2 square root. Then what is the value of MO2? What is the molar mass of oxygen? 32 upon what is the molar mass of hydrogen? 2. Then square. That is 16. 16 square root is how much? That is 4. 16 is how much? That is 4. So 4 means, what does it mean? That means hydrogen rate of diffusion is equal to 4 times of rate of diffusion of oxygen. That means hydrogen moves 4 times faster than oxygen. That means your hydrogen takes 4 times faster, means the movement from a particular container. If you allow to remove hydrogen, hydrogen moves faster, that is 4 times faster than oxygen. So this is compared to the rate of diffusion of different gas. So with respect to temperature, with respect to pressure, with respect to vapor density, remember vapor density D of any gas is equal to this relation, that vapor density is equal to molar mass by 2. So when vapor density given, you can multiply 2 to know the molar mass. If molar mass given, you divide 2 to calculate vapor density. So we can solve many problems using this formula. Any doubt you have, you can discuss with me to clarify your doubt. Okay, thank you all.